Welcome to my channel. My name is Bhawa Singh, and today we're diving into round 2 of our DevOps interview questions series. If you're serious about mastering DevOps, this round goes deeper, not just into tools, but into real-world scenarios and strategic thinking. We'll cover DevOps phases, preparatory steps, CBD versus microservices, shift-left testing, resilience testing, continuous versus automation testing, and more. Each question is carefully selected to build clarity, boost confidence, and get you ready for real interviews. So stay focused, take notes, and let's level up your DevOps journey together. Let's kick off round 2 with a fundamental one. Can you name the different phases in DevOps methodology and explain them? Sure, there are 8 DevOps phases. All these phases are interconnected and occur in a loop. The goal is to enable continuous integration, continuous delivery, and continuous improvement. So phases are: first, plan. This includes defining project goals, features, and roadmap. 2. Develop. This includes writing and managing source code using version control. 3. Build. This includes compiling code, running unit tests, and creating build artifacts. 4th, test. This includes running automated and manual tests to ensure quality. 5. Release. This includes approving and packaging the application for deployment. 6. Deploy. This includes delivering code to production or staging environments. 7. Operate. This includes monitoring and maintaining infrastructure, ensuring availability. 8. Monitor. This includes tracking performance, user feedback, and errors. Good start. That covers the DevOps lifecycle well. Let's move on to the next question. Can you tell me what can be a preparatory approach for developing a project using the DevOps methodology? Or imagine you're starting a new software project. How would you prepare it from a DevOps perspective? Yes, sure. Preparatory steps. These take place before implementing DevOps practices. These are one-time and foundational actions of any project. Basically, it sets up the technical foundation and collaborative culture. Like first step, understand goals, means what will be the business and technical needs, like faster releases, maintaining high availability. Who will be the stakeholders like Dev, Ops, QA, security, product team? What will be the architecture of the application, like monolith or microservices? Second step, build DevOps culture, means keep a mindset of shared responsibility. Keep cross-functional teams like Dev, QA, Ops, security working together. Follow Agile practices. Third step, choose tools. Here, select and set up tools for each stage of the DevOps lifecycle, like what tools will be used in source control, CI, CT, CD, monitoring, etc. Fourth step, plan infrastructure, means what infrastructure should be used, like cloud, on-premises, hybrid, and what tool to be used for automation, like Terraform or any other tool. Fifth step, secure early DevSecOps, means implement DevSecOps practice early with each commit so that security principles can be followed from planning stage. Sixth step, define CI/CD pipeline, means define and implement automation for code build, unit test, packaging, deployment, etc. Seventh step, containerize, means decide and implement Docker or Kubernetes, set up container registry. Eighth step, monitor everything, means decide and implement monitoring and logging. Ninth step, improve continuously, means improve by collecting feedback. Feedback can be collected from monitoring, from each sprint, from end users, from involved teams, and then act on the feedback. 10th step, document, means document everything like CI/CD pipelines, runbooks, architecture, developer onboarding. Great, that's a well-structured approach to setting up a project with DevOps in mind. Let's move to the next question. All right, here's an important one. Can you differentiate between preparatory steps and phases of DevOps? Preparatory steps are one-time and initial setup, whereas DevOps phases are ongoing software delivery. Preparatory steps start and execute before the DevOps pipeline, while DevOps phases start during the DevOps lifecycle. Preparatory steps focus on planning, configuring, and upscaling, while DevOps phases focus on automating and improving delivery. That makes sense. Understanding the distinction helps ensure we lay the right groundwork before entering the DevOps lifecycle. Let's move on to the next one. Can you tell me, what is CBD in DevOps? Yes, sure. CBD means component-based development, which is a software development approach where applications are built by assembling reusable, independent components, rather than writing everything from scratch. In DevOps, CBD supports modularization, faster delivery, and scalable automation by enabling independent development, testing, and deployment of each component. There are some examples of components in CBD, like authentication module, logging service, payment gateway, UI widget, email sender. Got it. That gives a solid overview of component-based development. Now here's a commonly asked one. What's the difference between component-based development and microservices architecture? All right, let's have a look at it. In CBD, there is code reuse, whereas microservices are a completely independent service. CBD is particularly well suited for large software projects, whereas microservices are designed to perform a single, well-defined function within a larger application. In CBD, a full bundle is deployed all at once, whereas microservices are deployed individually in a distributed environment. The boundaries of CBD are logical, that is in the code where the components can communicate with each other, whereas the boundary of microservices is technical, means a microservices will communicate with other microservices via network protocol. CBD usually does not deploy to Kubernetes like microservices, because CBD is a large software application, so it does not make any sense to deploy to Kubernetes, and CBD apps are not designed for distributed deployment, whereas microservices are designed for a platform like Kubernetes. But some CBD components can be deployed like microservices when CBD components are converted to microservices, but it does not make any sense because CBD components are tightly coupled, they are not service-oriented. That clears up the distinction well. Both have their place depending on the architecture needs. Let's move to the next one. What is resilience testing? Resilience testing is a type of software testing in which we ensure whether our system will be able to recover from unexpected disruption or failure, like crashes, hardware faults, network issues, or power outages. The purpose of doing resilience testing is to ensure that our system does not break due to stress and failure and recovers well. In resilience testing, we will shut down the server, disconnect the service. We will observe whether our system did auto-recovery, gave alert, retried, what was the impact on data integrity and service continuity, how much time did the system take to behave correctly post-recovery. Examples of what is tested. Application recovered a database crash. System handles network interruptions and retries automatically. Load balancer reroutes traffic after a node failure. Microservices continue to function when a dependent service is down. Common tools used: Chaos Monkey, Netflix, Chaos Toolkit, Gremlin, Litmus Chaos for Kubernetes. That's a solid explanation of resilience testing and its role in system reliability. Now let's take it a step further. So should resilience testing be part of the CI/CD pipeline? What's your take on that? The benefit of incorporating resilience testing into CI/CD is that the system will be able to handle real-world failures. Failures will be detected at an early stage. The team will also build confidence in the recovery mechanisms. Now, because of all this, the goal of DevOps of continuous delivery with high reliability will be helped. Now the question is how to include this in CI/CD. See, if we have to do lightweight resilience checks, then we can do it in CI as well. For this, we can simulate service timeouts, retry logic, circuit breakers, in unit and integration tests. And if we have to do stronger resilience testing, then it has to be done in CD, means do it in staging or pre-prod environment before deploying in production. For this, we can simulate by crashing the pod or service in Kubernetes, by making the database unavailable, by causing network latency or partition. Now the question is resilience testing mandatory in CI/CD? The answer is no, but highly recommended in CD stage. Should resilience testing be run on every commit? No, use it for nightly builds or pre-prod deployments. Should resilience testing be done whenever the code is released? Yes, especially for critical systems. Next up, here's a question that often comes up in real-world scenarios. Can you explain the shift left to reduce failure concept in DevOps? Imagine in SDLC, the phases are lined up like this: planning, design, develop, test, deploy, operate. So here testing happens after development. In shift-left testing, testing has to be shifted in the early stages of SDLC, like towards planning. In traditional approach, testing happens after full development, in which chances of failure are higher, because in this stage feedback of bugs, defects is received at later stage, when testing frequency is weekly or before release. And testing would be often absent in CI/CD, so feedback would come late. Whereas shift-left testing starts at early stage, in development, even during planning by integrating throughout the CI/CD pipeline. In this, feedback of test result comes on every commit. Now in shift-left testing, bug detection happens at an early stage. There is no need to rework, because if the issue is fixed at an early stage, it will not come up at a later stage. The quality of the code also improves. The delivery also becomes faster. There is better collaboration between dev, testing, and operations teams. So by shifting testing and validation earlier in the pipeline, we not only catch bugs sooner, but we also minimize production risks, reduce costs, and accelerate delivery. That's the real power of shift-left in DevOps. Now let's move on to an important distinction. Can you differentiate between continuous testing and automation testing? The key difference between continuous testing and automation testing is something like this. The purpose of continuous testing is to perform quality testing and consider feedback, whereas the purpose of automation testing is to perform automation testing by eliminating manual testing. The timing of continuous testing remains throughout the SDLC, whereas automation testing is usually performed in the test phase or CI pipeline. The scope of continuous testing is functional plus non-functional testing, whereas the scope of automation testing is mostly functional testing. The focus of continuous testing is risk reduction and early issue detection, whereas the focus of automation testing is to maintain the speed and accuracy of test execution. The integration of continuous testing is deeply tied with CI/CD, whereas the integration of automation testing may or may not be with CI phase. Continuous testing feedback is received immediately across all the stages, whereas automation testing feedback is limited only to the testing phases. Automation testing is a part of continuous testing, because continuous testing equals automation plus integration plus strategy. So in CI/CD, continuous testing is essential, and automation is just a part of continuous testing. So, while automation testing is the tool, continuous testing is the strategy, integrating testing across every stage of the DevOps lifecycle to catch issues faster and release with confidence. Now let's talk about a key practice for learning from failures. Do you know about post-mortem meetings in DevOps? Yes, when any incident or failure occurs, like deployed environment such as outage in prod, deployment failure, any security breach like hackers attempted hacking on servers or network performance degrades. Then a meeting is organized, which is called post-mortem meetings, in which it is investigated why the incident happened and how it can be prevented from happening in future. Now remember that post-mortem meetings are not about blaming anyone, because DevOps believes in blameless culture. In fact, these meetings focus on process and system improvements and encourage sharing mistakes honestly. Let's move to the next question. Can you tell me how DevOps is different from the Agile methodology? Yes, sure. So there are some keys which we can consider to explain the differences between two methodology. And these keys are 1. Focus area. 2. Scope. 3. Teams involved. 4. Goal. 5. Speed versus stability. 6. Tools and automation. 7. Release cycle. 8. Feedback loops. 9. Culture. 10. End outcome. Let's understand these key differences. 1. Focus area. Agile focuses on software development, whereas DevOps focuses on both development and operations. 2. Scope Agile covers the SDLC from planning to delivery of software, whereas DevOps covers end-to-end delivery, which includes development, testing, deployment, operations, and monitoring. 3. Teams involved. Here, in Agile, developers, testers, and product owners are involved, whereas in DevOps, developers, QA, operations, security, and release engineers are involved. Fourth goal. Here, in Agile, working software frequently and incrementally is delivered, whereas in DevOps, continuous integration, delivery, and deployment with automation and stability is achieved. 5. Speed versus stability. Here, in Agile, speed of development is emphasized, whereas in DevOps, speed with reliability and uptime is balanced. 6. Tools and automation. Here, Agile relies more on collaboration and planning tools like Jira, Trello, whereas DevOps uses CI/CD, automation, infrastructure as code tools like Jenkins, Docker, Kubernetes, Ansible. 7th release cycle. Here, in Agile, releases are planned in sprints typically between 1 to 4 weeks, whereas DevOps enables on-demand releases, even multiple deployments per day. 8. Feedback loops. Here, in Agile, feedback are taken from users and stakeholders after each sprint, whereas in DevOps, feedback are taken from automated monitoring, logs, and user behavior in production continuously. 9. Culture. Here, Agile promotes collaboration within the dev team. DevOps promotes cross-team collaboration between Dev, Ops, and QA. 10. End outcome. Here, in Agile, final result will be working software that meets user needs. In DevOps, final result will be working software that's fast to deliver, reliable, and easily scalable in production. Let's move to the next question. What are the common branching strategies used in version control systems? There are various branching strategies used in version control systems like Git. First, main or master-only strategy. Here, no branching is used, only main or master branch is used. This is good for small or solo project. Second, feature branching. Here, a separate branch is created for each new feature and merged back into main after review and testing. It's popular in agile and collaborative environments. Third, Git flow. Here, a structured branching model for managing releases is followed. We can have different branches here, like main, develop, feature, release, hotfix. This is good for large teams. Fourth, GitHub flow. Here, branch is created from main branch, and changes are pushed to new branch, and then open a pull request, review it, test it, and merge it. This is best for continuous deployment environments and popular with startups, open source, DevOps teams. Fifth, GitLab flow. This strategy combines Git flow with environment-based branches like staging, production. This is tied closely with CI/CD pipelines and issue tracking, and it focuses on real-world deployment. Sixth, trunk-based development. Here, all developers work on a single shared branch like main or trunk. Branches, if any, are short-lived, merged quickly. This is best for high-speed teams using CI/CD or DevOps. Branches, if any, are short-lived, merged quickly. Seventh, release branching. Here, separate branches are created for each versions like Release 1, Release 2. This is used in enterprises with long-term product support. So that wraps up our discussion on branching strategies, an essential part of collaboration in any version control system. And with that, we've completed all the questions for round 2 of our DevOps interview series. Remember, DevOps isn't just about tools, it's about mindset. As the saying goes, the best way to predict the future is to build it. So keep learning, keep experimenting, and keep building. See you in round 3. Your DevOps journey is just getting started. Thanks for watching DevOps by Bawasi. If you found this helpful, don't forget to like and subscribe for more DevOps and real-world how-to content. Until next time, keep learning, keep deploying.